Hello, my dear friends. How are you all? I hope you all are awesome. So, you are very welcome in our lecture number 2 of polynomials. Okay, so I hope you will enjoy this lecture. So, without wasting the time, let's get started. Yes. So now in previous lecture you learnt about what is polynomials. Okay, types of polynomials, what is degree, what is zeros of the polynomial. Now here we learn about geometrical meaning of the zeros of a polynomial. Okay, yeah, it is very amazing and interesting topic. Okay, so basically what is happening, zeros of a polynomial are the coordinates of the points, okay, where the graph of y is equals to f of x intersect the x-axis. Means if you see in this graph, okay, here is a linear line which cut x-axis at one point, which cut x-axis at one point. Okay, now here is, we can say there is 1 0 1 0. Now if you see this is a parabolic curve. Okay, and it cuts the x-axis at 2 points, at a and b. So here we can say that there is two zeros, there is two zeros. I hope you get this point. Yes. Now if you see the third graph, okay, so here is 3 cut at the x-axis at a, b and c. So we can say that there are 3 zeros at the x-axis. Okay, so I hope you get this point. So here a, b and c corresponded to the zeros of the polynomial represented by the graph. Okay, so I hope you get this point. Now let's move on. Yes, number of zeros. In generally, a polynomial of degree n, okay, a polynomial of a degree n has at most n zeros. Means if we have a linear polynomial, so what is the maximum degree of linear polynomial? 1. So linear polynomial has 1 0. Okay, so zeros depend on the degree of the polynomial. If we have the quadratic polynomial, so quadratic polynomial has two zeros. Okay, I hope you get this point. Now if you talk about cubic polynomial, okay, if we talk about third point, cubic polynomial which has three zeros. Okay, so now I hope you understand these things. So number of zeros depend on the degree of the polynomial. If it has 4 degree, okay, so the zeros are, so the number of zeros are 4. Okay, I hope you get this point. Now let's move on. Yes, now we are talking about representing equation on the graph. Okay, now we are represent these all type of equation on the graph. Okay, so let's do that. So any equation can be represented as a graph on the Cartesian plane. Okay, where each point on the graph represent the x and y coordinate of the point that satisfy the equation, equation. Okay, so an equation can be seen as a constraint placed on the x and y coordinate of a point, and any point that satisfies that constraint will lie on the curve. Okay, so for example, we have an equation y is equals to x. Okay, we have an equation y is equals to x. So on this graph, okay, on a graph, it will be a straight line. Okay, it will be a straight line. Okay, now that join all the points which have their x coordinate equals to the y coordinate. For example, if we have x is equals to 1, then we also have y is equals to 1, so our coordinate is 1 comma 1. If we have x is equals to 2, then y also equals to 2, then we have what is, yes, 2 comma 2. Okay, and so on. So if you draw these coordinates on the graph, we get like this. Okay, we get like this type of graph. So this is the graph which is represent the what, which is representing the equation. Okay, so now you can see that if x is equals to 1, then y is also 1. If x is equals to 2, then y is also 2. If x is equals to 5, then y is also 5. If x is equals to minus 5, then y is also minus 5. Okay, I hope you get this point. So now, geometrical representation of a linear polynomial. Now we are representing the linear polynomials on the graph. So the graph of a linear polynomial is a straight line. Okay, let's suppose we have an equation like this. Like what? Like, okay, y is equals to ax plus b. We have an equation and this is a polynomial, linear polynomial. Okay, we can say that it is a polynomial. So it cut the x-axis exactly at one point. Exactly at one point. Okay, so we know that graph of a polynomial is a straight line, so it is called the linear polynomial. Since a straight line can be determined by the 2 points. Okay, so only 2 points need to be plotted. Okay, so only 2 points, just 2 points we need to plot to the graph, okay, of this linear polynomial. The graph of y is equals to ax plus b. Okay, so what are these points? If we put y is equals to 0, then we get x is equals to minus b by a. Okay, if we put again, okay, so now if we put x is equals to 0, then we get y is equals to b. So by using these two terms, by using these 2 points, we can draw the graph very easily. Okay, let's suppose this is the equation y is equals to ax plus b. Okay, and this point is r. Here is y 0, then this is point b. Okay, so we can write it as 0 comma b. Here is y is 0, so we can write minus b upon a comma 0. Okay, so I hope you get this point. Now let's move on. Yes, so now geometrical representation of a quadratic polynomial. So the graph of a quadratic polynomial is parabola. Okay, so graph of the polynomial is what? Yes, the graph of quadratic, the graph of quadratic polynomial is what? Is a parabola. Okay, so it look like just a U shape, means like this. It may be this, it may be upward, it may be downward. Okay, like this, which is either open upwards or opens downwards depending on the value of a in, depending on the value of a in ax square plus bx plus c. Okay, so this graph depending on the value of this a, like this a. Okay, so now if a is positive, then parabola opens upward. Okay, if a is positive, then parabola it look like this. Okay, if a is negative, then parabola look like this. It opens downward like this. So it can cut at x-axis at 0 or 1. Okay, so it cuts the x-axis at 2 points. So that's why we can say that quadratic polynomial has how many number of zeros? Two zeros. Okay, because it cuts at x-axis at 2 points. Okay, yeah. So it look like just as yes. So here is graph of a polynomial which cuts the x-axis in two distinct points. Here a is greater than 0. A is greater than 0 means a is positive, and for positive the graph it opens at the upward. Okay, so it look like this. So this is the parabolic graph of quadratic polynomials. Okay, I hope you get this point. Now let's move on. Yes, now listen to me very carefully. This is the graph of quadratic polynomial which touches the x-axis at one point. It touches the x-axis at 1 point. Okay, yes. So this is the graph of quadratic polynomial that doesn't touch the x-axis. Now this is not touch at the x-axis, and which is having a is less than 0. A is having less than 0. Okay. Now graph of the polynomial which having x raised to power n. Okay. Now graph having higher degree of polynomial. So for a polynomial of the form y is equals to x raised to power n. Okay, for the polynomial of this type of graph where n is a whole number, where n is whole number means it is a round figure, it is not a fraction or not a decimal, whole number. Okay, so as n increases, the graph becomes steeper or draws closer to the y-axis. There are some conditions. Let's just say as n increases, the graph becomes closer to the y-axis. Okay, I hope you get this point. Now second condition is that if n is odd, the graph line in the first and third quadrant, the graph lies in, so the graph lies in the first or third quadrant if n is odd, then the graph lies in first and third quadrant. Okay, so I hope you know what is quadrant. So the quadrants are like this. This is our first quadrant, this is a second quadrant, this is our third quadrant, and this is our fourth quadrant. So here in first quadrant, x-axis is positive and y-axis is also positive. In fourth, so here coordinates are like positive, positive. So in third quadrant, x-axis is negative and y-axis is positive. So here, here the coordinates are negative, positive. Now, in third quadrant, x-axis is negative and y-axis is also negative. In fourth quadrant, x-axis is positive but y-axis is negative. So we can write coordinate like this. So I hope you get this point. Now, let's move another point. If n is even, if n is even, then the graph lies in the first and second quadrant. Graph lies in the first and second quadrant. Then the graph lies in the first and second quadrants. Okay. And the last point is that the graph of y is equals to minus x raised to power n is the reflection of the graph of y is equals to x raised to power n on the graph. Means if we have a graph like this, y is equals to minus x raised to power n, then it is the reflection of what graph? Y is equals to x raised to power n on the x-axis. Okay, so suppose it becomes like this. This is the graph of y is equals to x raised to power n. Then so what is the graph of y raised to y is equals to minus x raised to power n? Like this. This is like this. So this is the graph y is equals to minus x raised to power n. Okay. So I hope you get this point. Now, yes. So graph of polynomials with different degrees. With different degrees. So here we can see that if you see, as the value of n increases, as the value of n is increases, then it goes to the closer to the x-axis. Okay, here y is equals to x raised to power 7, which is very closer to the x-axis. Okay, which is very close, oh sorry, y-axis, which is very closer to the y-axis. As the power of n increases, it draws very closer to the y-axis. Okay, and it lie in the first and third quadrant. First and third quadrant. If x is, if n is odd, if n is even, then it lies in second and first quadrant. Second and first quadrant, like this. So it is, this is our graph of x is equals to y is equals to x square, and y is equals to x raised to power 7. We have like this graph in first and third quadrant. Okay, so I hope you get this point. Okay, so now let's just do an example. So friends, we have a graph y is equals to p of x of polynomial are given. For some polynomials p of x, find the number of zeros of p of x. In each case we have to find the number of zeros. So in first case, can you tell me how many number of zeros are there? Zero. So there are no zeros in the first case because it is not cut on the x-axis. Okay, so in that case, how many zeros? One zeros, because at one point it is cut on x-axis. In that case, there are three zeros. There are three zeros. Why? Because the polynomial cut x-axis on third point, on 3 points. Okay, now in that case, again there are two zeros. In this case, how many zeros? One, two, three, and four, means four zeros. In this case, one, two, three. There are three zeros. So I hope you get this point and you can find easily by seeing the graph how many zeros are there. Okay, if it cut x-axis on x-axis for three times, then the zeros are three. If it is not cutting x-axis at any of the point, then it has no zeros. Okay, so friend, I hope you get this point. Now here we are finishing our lecture, and now we will meet in the next lecture. So thank you very much guys for listening me.